Hi there, my name is Ron Rogers, and this video is titled How I Accidentally More Than Doubled the Accuracy of the B-52 Radar Continued. And does it take a good program manager to get a D-? Now, I had a lot of people comment, and you made some very nice comments. I really appreciate that, about the uh, video on the B-52 radar, and you kind of wanted more detail. So I'm going to give you a little more detail. Now, still, um, there's a lot of things classified on this, and it's still an operational antenna. So, I can't say certain things, but I can still give a fair amount of information. Now, like I mentioned, the main thing about this program and my contribution to it was the feed horn choke under the radome. Now, I said I was lucky on this, and a lot of people said, no, it's skill and things like that. But it was lucky in the fact that the antenna had not been worked on for a very long time. And by being given the antenna to work on, I could apply some reasonably easy solutions to correct a problem that probably should have been corrected really in the individual design if they had known about it back in the time it was originally designed. Now, the blue arrow points to the radome that's over the feed horn choke, and the orange arrow points to the base of the radome that is attached to the feed horn choke. And what they basically did was they made a couple of cuts around the circumference of the radome there, where the orange arrow is pointed, and they were able to remove it very nicely without damaging the radome from the feed horn choke. Now, part of the original problem of this whole thing, and this was back, like I said, in the early 80s, and the attitude back then is, well, we can solve problems just by signal processing, and we have a lot better capabilities. We don't use tubes anymore. We don't use the little pixie tubes, and we have a lot more processing capability, so we can handle a bad signal and do wonderful things. Well, guess what? Garbage in, garbage out. You can't process that greatly a poor signal. Now, I know people do amazing things with algorithms and get signal out of noise, but you're getting kind of crap into the system, and that's kind of what you got out. Now, here is the feed horn with the choke attached. The orange arrow points to the feed horn itself. The yellow arrow points to the choke, which is, of course, the ring structure there. The red arrows point to the radar absorbing material that was put around and in the choke, and also on exterior parts of the feed horn. And I remember this radar absorbing material, this is back in the early 80s, was $144 a square inch. The blue points to the base of the feed horn, and this is where the radome was glued on. And like I mentioned, it was cut off. They put 3 cut points there, and they were able to remove it without damaging it. They cleaned everything up, and they were able to reattach it. Now, this is my hand-drawn representation of the Null before and after the feed horn choke was installed. The black trace is generally how the Null looked when you would run it through the frequency bands and swing the antenna. Now, you notice the Null is fairly wide and not very deep. It had a certain specification it had to meet, and at the time, this met the specification. Now, remember, the B-52 was originally a high-altitude bomber, so the terrain avoidance wasn't as critical as it became later when it became a low-altitude penetrating bomber. So, fairly unfocused, but it was a decent enough signal at the time. The orange trace is the result of putting the feed horn choke on. Now, the vertical scale, which is unlabeled here, is in dB, and so a little bit of distance makes a big signal difference, as I'm sure you know. So what the feed horn choke did was it focused the beam. It's narrower, and it dropped much, much lower. In fact, that bottom line there indicates the bottom of the case. These are all mechanical chart pointers there with ink on them. And when we ran this, it actually bounced off the bottom of the case there. So it was really far down there. Probably was getting to the limits of our ability to measure it, and the ability of the equipment to be accurate in this range. But it obviously was a very deep null. And as I mentioned on the other video, this is where the technician and I looked at each other and laughed, and it's got to be a bad connection. Checked it, spent another 45 minutes, and then I said, well, okay, if it's really true, we'll come off bore sight, and it should come up. And we actually came off bore sight, and it did come up, and we did kind of a three-dimensional tracing, and it's actually off bore sight. It still met the on bore sight parameter, so that was kind of interesting. And surprising. And that's when I went to my boss and said, got an interesting result. Now, another aspect of this is the sweep, where as the frequency changes, the trace changed. This is because it was basically unfocused, just like light entering an eye that has astigmatism. It spreads out, and that's why the image is diffuse and not very clear. So various frequencies, we get this scatter here, and there was a wishbone pattern that you laid over this, and it was supposed to be inside this wishbone pattern. That was part of the parameters for making this antenna work. Now, when you put the feed horn choke on, of course, it focused the beam, and now these traces really well aligned. So it's like, does this lens look better, or does this lens work better? You get to the point where it's all focused and it works kind of nice. Well, as I mentioned, I got, recognition for this. But the interesting point was it was too good. I was told it was too good. I was told we were getting an A on this program, which is why the Air Force came in and kind of wanted to know what happened. Because why did we go from a program that had been failing for months until one that all of a sudden, never mind, it's working great. And it's not only working great, it's working beautifully. So I'm in the program manager's office, and he says, we don't need an A. We didn't budget for an A. We didn't charge the Air Force for an A. We charged for a passing grade, and a D- is a passing grade. Now, as an example, he showed me 2 letters on his wall. And these letters concerned a line replaceable unit for an Air Force aircraft, an LRU. And it concerned EMI, electromagnetic interference filters, that were in the unit. When you have an LRU like this and you have cabling in the aircraft, you can get signals that impinge upon the cabling in the aircraft, and they follow the cabling into the line replaceable unit and cause problems. So what you do is you put a little filter in there. Well, the Air Force wanted to save money on this box, so he came up with the idea of removing the filters, and it saves some money. So he got a letter of commendation for removing these filters and the cost savings and all that wonderful thing. Well, lo and behold, they started having problems with these boxes. They were experiencing EMI interference. And he goes, okay, Boeing gets another program. They go, you need to solve this problem. So they did. And what he did was he put these filters back in. So it solved the problem. So he had a letter of commendation for putting the filters back in. And I said, you got to be kidding me. You're proud of this? And he pointed the first letter and says, Boeing made money by taking the filters out. He pointed to the second letter and he said, Boeing made money by putting the filters back in. He said we made money on both programs. And he was pleased with that. Thanks for watching.